All right, let us proceed from where we left off. As I mentioned that I'll be looking at the domain of the function and also touch on the axis of symmetry. So let us look at domain. So this would what we did in the last part that we focused on was the asymptotes. So drawing back from the asymptote, we can tell what is the domain, we can tell what is the range by looking at the equation and its restriction. So we must also look at what is the range. So domain. Remember our function, we're looking at a relationship between the x values and the y values. And if you look at the term domain, look at the term range. Domain starts with D, range starts with R. And the letter D comes first in alphabetical order. In alphabets, yeah. And if you look at the coordinate itself, it's xy. So x, we start with x, then follow with y. So domain will therefore associate itself with the x values. So what is a domain? A domain would refer to the x values in which the function is defined. So these are x values in which the function is defined. In other words, where the graph exists, all sets of real values in which the function is defined. So range would therefore refer to all sets of y values in which the function is defined as well. Right. Now let's draw back to asymptote. What did we say about asymptote? Asymptotes, we said these are imaginary lines in which, or imaginary point in which the graph will tend towards or approaches, yet it never touches. So to say at that particular point the graph does not exist, therefore it is not defined at the asymptotes. So we mentioned that if we have the graph y is equals to a over x plus p, then plus q. The asymptotes we have horizontal asymptote and we have vertical asymptote. So horizontal asymptote, it cuts through the y values, and vertical asymptote cuts through the x. So the y asymptote will be y is equals to q, and vertical asymptote would be x plus p equals to 0, and therefore x is minus p. Note that I'm using the equation that I've written on the side. So these are points in which the function does not touch. It doesn't exist at that particular point. Or lines, equation. There are functions as well. Y is equals to q is a function. X is equals to minus p. That okay, we'll discuss that when we get to the grade 12 content, but it wouldn't be a function, but it's just the equation of a line that moves vertically, cutting through the x-axis. So through those lines, the graph does not exist. So therefore, through that point or line, the graph is not defined. So it becomes easy then to write our domain. So it's only one point, one x value, one y value, where the graph does not exist. So when we talk of the domain, so the domain would therefore say, okay, all sets of x values are possible except when x is equals to what? Negative p. Remember that? If x is equals to negative p, remember the function is undefined, or that is our asymptote. Then when you look at the range, you're looking at all sets of y values which are possible except when y is equals to q. Remember, y is equals to q is an asymptote and the graph does not exist there. X is equals to minus p according to the equation. The function does not exist. So therefore, they are not defined in those areas of values. So x cannot be minus p because it will make the function undefined. Q cannot be, rather, y cannot be q because it will make the function undefined as well. All right, so these are therefore the domain and range of our function. So that is how you would find that. Another way would be looking at the graph visually. So let's draw a Cartesian plane like that. And let me have my asymptotes. These are asymptotes. It's fine. Let's have them here. All right, of course, this will be x is equals to negative p. Remember, it can be anywhere as long as we know what the value of p is. Okay. All right. But yeah, that will be my asymptote for now. But I will be contradicting myself because I mentioned that let's make our p positive. All right. So let me move it here. Okay, I'll put it on the other side. So let's put it here. Okay, therefore, let's draw a graph maybe like this. And also like that. Like that. So that will be our rough sketch there. So I want you to look at moving from the left and moving to the right. Domain, remember, it refers to the x values. So our x values runs from the negative values to positive values. So let us observe from the negative side towards the positive side. I would say, can you draw your graph without lifting your hand or removing your hand? Note, I want you to draw both arms of this function without lifting your hand. So if I would try from the negative infinity, there it goes, then I draw. But for me to move to the next one, what happens? I will have to lift up my hand so that I start drawing the other arm. So therefore, that tells us about discontinuity of the graph. So therefore, I can't draw it without lifting my hand. So that means there is a restriction. What are those restrictions? Is that x is not equals to negative p, and okay, I'm talking about left and right, so that will be affected by the x values. So if we that you can now you can see where the restriction is. Your graph, you can't draw it without lifting your hand. And where do you now lift your hand is when x is equals to minus p. So that means at that point the graph does not exist. So all values of x are possible except they. With the y values, which we talk about the range, we look at bottom to top, bottom to top. So from the bottom, far bottom, we are moving from negative infinity, or rather y values there. So as we go up, we can draw this graph again. Then we can't continue to go up because there is a restriction. Where is the restriction? Is at y is equals to q. And for me to draw the other arm, I will have to lift up my hand again. Do you see that? So in that case, it implies that there is a restriction. So that restriction is the one that determines whether our domain will be set of all real values um, with no values in or restricting us. But we can see that um, there is a restriction. So therefore, that restriction says you can take everything on the y values except that particular one y value. Our graph is not defined there. Okay. Now let us look at okay, touched on the domain. So if the p-value is not given, that means you know that your p-value is 0. If the q-value is not given, you must know that your q-value is 0. Now, on the same graph, there are lines that split the graph into two equal halves. So they more like bisect the graph. They split the graph into two equal parts. These lines, we call them axes of symmetry, or rather symmetry lines. They divide the graph into two equal parts. Maybe not straight, but that's how it will be looking. And there's another one. And all these lines, they pass through the point of intersection of the asymptote. I may not indicate the arrows, but just know that our graph are continuous. Unless we bring in restrictions, you'll be informed of that. So let us look at the axis of symmetry. So if you look at the lines, they are straight lines. They split the graph into two equal halves. So if they do that, then we have their equations. They are given by y is equal to x plus c. And the other one is y is equals to negative x plus c. So why the other one is positive, why the other is negative? Look at the graph. If you look at the graphs, one has a rising slope or increasing slope, positive slope. You get that? And there's the other one that is having a negative slope or decreasing graph. If you look at this one here, let me call it A. And if you look at B, A graph, it's rising, so therefore it's having a positive slope. B graph, it's falling. We are reading from left to right, remember? B graph, it's falling, so that means it's having a negative slope. So this one is your A graph, and this one is your B graph. A graph has a positive slope. Positive slope. If you don't want to say positive slope, you say what? It's a positive gradient. So at times in exam questions, they would specify which equation they need you to find or use. And this one, the B graph, we can see with the minus x, so that means it has a negative slope. It has a negative slope, or we can say gradient. So they are symmetry lines. Lines can, functions can be reflected about that at times. So there are point of intersection here, in which for you to find them, you must equate the two graphs, the curve, and one of these as axis of symmetry, depending which one is intersecting the graph. So this common point here, this one here, okay, let me use a different color because it might mix up the work. This common point here, this is your negative P and your Q. So these are the values: asymptote, vertical asymptote, and horizontal asymptote. The x values and y value, they make a coordinate, and this coordinate, it's where the asymptote meet or cross each other, and axis of symmetry, they also pass through that point. So it's a common point. So you'll be asked to find the value of C, and to find it, you can substitute that coordinate. Another way to look at this would be, let me first write, okay, use negative P and Q. So the negative P and Q, these are the x, they are coming from the equations of asymptotes. All right, so whatever P is or Q is, that's the coordinate you're going to use. You're using this to find let's say the value of C. So another way to look at this, you're not limited to that. Y is equals to, let's say, A over X plus P plus Q. If you are given this function, so we are going to say Y is equals to, open bracket, take the denominator as it is, then we add Q. So you can see that in front here we have a positive. Then the other one, I'm going to say Y is equals to negative, open bracket, X plus P plus Q. So this will give us the other part of with the negative slope. Note, this is our A graph with a positive slope, and this is our B graph with the positive slopes. So here you don't need the coordinate to find C. As long as you know your P and Q, then you are done. Just take it as it is from the equation. So this, there, and there. See, those are X of symmetry. So there are questions that you'll be asked to find these. So yeah, so both method will work, whichever that you are comfortable with. That's the one that you would use the most. So I have a question that I would like to touch on. Let me do it in the next video, as this video might be long, because with the question there's so many things to unpack. So therefore I'll pause here and I will continue in the next video. Please watch and please share with the others. Thank you so much.